Okay, right. In question 8, they say in the diagram below, circle T touches the x-axis at R. So T touches the x-axis at R. So basically the x-axis is also a tangent of that circle T. And then they say that AO is a tangent to the circle at P. So that circle has two tangents. It is tangent OA and the x-axis as well. Ne? Then they say that OT is equals to 5. So let's just put that OT there. Let me just draw it much beautifully. Right, so we are told that OT is 5, right? So OT is 5, and then we also told that TP is 3. So I'm gonna draw TP, and we are also told that TP is 3. I meant to say, right? That is 3. Now, in the question, they say that determine the coordinates of T. Now, to find the coordinates of T, now we're gonna need to prove first that OP is equals to OR, and then in that way we can actually find the coordinates of R. After finding the coordinates of R, the x coordinates of R is gonna correlate to the one of T, and then finding the y coordinate, it will be much easier, which you're gonna see along the steps. So for us to first prove that OR is equals to OP, we're gonna have to first draw a line coming from T touching R. All right, and then from there onwards, we're gonna basically prove that triangle OTP and triangle OTR, they're basically congruent to each other. If they are congruent to each other, then we can actually prove that OR is equals to OP. All right, now let's do that. Now, can you see that PT and TR, they're going to basically be the same length, which is going to be 3, right? And the reason for that is going to be because of the radii. And then can you see that that angle there is going to be 90 degrees? I mean to say this will be 90 degrees because of tangent perpendicular to radius. And also here, that angle there is also going to be 90 degrees because of tangent perpendicular to radius. But now let's just write down all of everything that I just said right now. So we're going to say that in triangle OTP and triangle, sorry, and triangle OTR. OTR first. So first we found, let me call that angle 1 P1, that P2. Let me call that PR1, and let me call that R2. All right. So we're gonna first say that angle P1 is gonna be equals to 90 degrees, and the reason is because tangent perpendicular to radius. So I'm gonna write that down. So it's going to be basically OA perpendicular to PT, right? And then another one is going to be R1 equals to 90 degrees, and the reason for that is because of tangent perpendicular to radius, and that radius is going to be x-axis, right? It's the x-axis perpendicular to RT or TR, I mean to say TR. All right, now basically now I can just say that P1 is equals to R1, and the reason for that is that both equals to 90 degrees. All right, and then another thing that I need you to know is that OT is a common side. OT is a common side. And then another thing as well is that TP is going to be equals to TR, and the reason for that is because of radii. Right, now I can say therefore triangle OTP is congruent to triangle OTR, and the reasons for that is because of RHS. Now remember, RHS stands for the right angle, and then H stands for the hypotenuse, which is OT being the common side, and then the side stands for the radius there, which is any side. Now if those triangles are common to each other, now I can say therefore OP is equals to OR, and the reason is because those triangles OTP is congruent to each other. OTR. Alright, so now we have proven that OP is going to be equals to OR. Now to find the length of OP, I'm going to say in triangle OTP. Now remember, OP squared is going to be OT squared minus TP squared, and the reason for that is going to be theorem of Pythagoras, right? So it's OP squared equals to 5 squared minus so it's 5 squared minus 3 squared, right? And if you do that, so it's going to be square root OP squared equals to square root 16, and then OP is gonna be just 4 units. Therefore OR is going to be also equals to 4 units. Alright, now let me change the color. Let me just write down the other steps there. Now if OR is 4 units, so we have found that OR is 4 units. What I want you to get that the coordinates of O is 0, 0. Right? Now to find the coordinates of R, remember if we wanted to calculate the length of OR, we were going to say OR equals to the x coordinate of R minus the x coordinates of O, because we don't have to use the distance formula, seeing that those two coordinates, they have the y coordinate being common, which is 0. Now remember, we just found that OR is 4 XR minus 0, so basically XR is equals to 4. Now can you see that TR, they basically lie on the same line, which is line TR. Now if the coordinates of R, so if the x coordinates of R is going to be 4, it just means that therefore xt is also going to be 4. Now the coordinates of R, there's just going to be 4, 0, because can you see that it touches the x-axis, so R is going to be 4, 0. And then another thing, now to find the coordinates of the y coordinates of t, let me use a different color. Remember the length, we were going to say rt, we're going to say rt equals to yt minus yr, because also here we don't have to use the distance formula, seeing that the x coordinate is common for both, which is going to be 4. Now remember, rt is a radius of 3, so we know that the radius is 3, and then yt is going to be yt minus, and then the y coordinate of r is 0, right? It's 0, so yt is basically going to be 3. Now we can say that therefore t is going to be 4, 3. So the coordinates of t there is going to be 4, 3. All right.